All right. I think we'll have more folks join us, but to be conscious of time, I'll kick us off. Welcome, everyone. Welcome to this 2025 forecast webinar with the University of Washington Alaska Salmon Program. My name is Frances Bursch. I'm the program manager at the Bristol Bay Regional Seafood Development Association. Before I introduce our speakers, I want to remind people you are encouraged to ask questions. This is a great opportunity to really get a good understanding of this forecast, and we have the time of these scientists, so really encourage the questions. Your options for asking those questions are using the raise hand feature in the bottom menu or the Q&A feature, the little box with the question mark there if you prefer to type in a question. We will pause after each of the four presenters for questions, but they've let me know it's okay if you have a really burning question while they're speaking to pop into either that raise hand or the Q&A, and they'll try to answer that right away. If you are listening in from the phone and you'd like to speak and raise your hand, press *9, and that'll show up for us on the screen. We can allow you to unmute and ask that question. That's *9 again. Okay, with that, I'll introduce our speakers. We'll hear from Chris Boatwright, Dr. Daniel Schindler, Dr. Curry Cunningham, and Dr. Ray Hilborn today. And to kick us off, we'll start with Chris Boatwright. Chris is the General Manager and Research Scientist with the University of Alaska Salmon Program.
All right. Thank you very much, Frances, and thanks to RSDA for setting this up and facilitating us to talk about a good portion of our forecasting work. And I will start us off here with a review of the 2025 University of Washington FRI Bristol Bay Sockeye Salmon preseason forecast. So I tend to like to start the review of the preseason forecast with the most basic table we generate, and that's what's on the screen here now. So it is the body of the table is 36 individual predictions or forecasts, if you will. So that's a prediction for each of the 4 dominant age classes of sockeye that return to Bristol Bay each year. So that's 1-2s, 1-3s, 2-2s, and 2-3s. The number to the right of the decimal is freshwater age. The number to the left is freshwater age. The number to the right is ocean age. And I tend to think of these by just ocean age. So 1-2s and 2-2s are 2 years in the ocean, and 1-3s and 2-3s are 3 years in the ocean. So a prediction for each of the 4 dominant age classes by each of the 9 contributing river systems in Bristol Bay. And so it is those 36 individual predictions that sum to get us to our total expectations for Bristol Bay sockeye returns in 2025. And that is 54.07 or 54.1 million sockeye we would expect back in 2025. So from there, kind of a step back and look at the primary data set that these predictions or forecasts are built on. So what we're looking at here on screen now are Bristol Bay sockeye salmon returns 1963 to 2024. So each of the production or the returns from each of the river systems are represented here with a different color band. And so it is this historical return data set coupled with explicit age data for sockeye that's collected and made available by the Alaska Department of Fish and Game. This is the primary data set that these forecasts are built on. And I think most interesting here is this last decade that everyone's really familiar with. We've seen record-setting returns. It's been characterized by really strong returns to all the river systems. But very interestingly, if we look at the green and the gray band, we can see that during this time period, the west side, or specifically the Nushagak district rivers, have really come on to be significant, if not dominant, producers for much of these big returns. So, but specifically here today, we're looking at the next chapter, so to speak. That is our expectations for 2025. I've popped onto the screen now on the right-hand side in that red column what our expectations for 2025 would look like relative to past production in Bristol Bay. So that brings us to the forecast table as we release it each year in early November. The left-hand side is that table that we started with, the 36 individual predictions that sum to give us our total Bristol Bay forecast for 2025 of 54.1 million sockeye. To the right of the column that shows those that forecast totaled by river system, we have our estimate for expected escapement given a run of this magnitude to Bristol Bay, and specifically runs of this magnitude to each river system. We get to that escapement estimate by considering realized escapements in the past relative to run sizes for each of these river systems of the magnitude we have forecast. We also give some consideration to a current escapement goal policy. And then next to the estimates of escapement, we have an estimate for Bristol Bay fish taken outside of Bristol Bay. Specifically here, we're talking about Bristol Bay fish taken in the South Peninsula catch. We set that to 1 million sockeye in 2025. And just to back up a little bit, our expected escapement for 2025 would be right around 15.26 million sockeye off a total return of 54.1 million sockeye. So we take both of those, our estimate for escapement and our estimate for Bristol Bay fish taken outside of Bristol Bay, and we remove those from the total return there by river system. And we come up with an estimate of inshore harvest numbers, or sockeye harvested taken inside the Bristol Bay's commercial fishing districts. So we would expect an inshore harvest right around 37.8 million sockeye off a total return of 54.1 million sockeye. So certainly to get the most out of any forecast, and certainly this forecast, you really have to consider forecast accuracy or forecast performance over some extended time period. And so now on screen, we've got a two-panel graph, a top panel and a bottom panel that does exactly that. So we'll start with that top panel, which is percent deviation in the FRI forecast from the actual return numbers across the time series 2000 to 2024. So those actual return numbers are set to that zero line there. And then, of course, red columns that fall above would be the percent deviation in those years. Those would be over forecast. And likewise, those blue columns that fall below that zero line would be percent deviation or under forecast from the actual return number set to that zero line across this time series, 2000 to 2024. So across from 2000 to 2024, the mean absolute percent error, average percent error across this time series is 15.2%. So a real quick look at that bottom panel. So the observed data, or the actual return numbers across that same time series, 2000 to 2024, are the blue data points connected by a dotted blue line. And then, of course, the values for our forecast, the FRI preseason forecast in those years are shown with the red line. And really all this does is kind of give us an idea of how these forecasts track to the real data, to the observed return numbers in Bristol Bay across this time series. What it shows is that these forecasts track pretty well. You can see there from 2016 to 2021, when we had those really huge runs, we saw a bit of consistent under forecast in those years. Most of that forecast era was predominantly in the 1-2 age class across that series of years. We just had really strong production in different river systems in the 1-2 age class that caused a little bit of an increase in forecast era across those years. So we then take this estimate of inshore harvest that we looked at on this forecast table. So inshore harvest in numbers of fish, and we translate that into a forecast, what I call a forecast, Bristol Bay preseason forecast in pounds. So this would be pounds, a projection of pounds harvested off a inshore harvest of 37.8 million sockeye. So this table is now organized again by the four dominant age classes of sockeye that return, and this time we organize this table by the Bristol Bay's 5 commercial fishing districts. And so we would expect, off of a harvest of 37.8 million sockeye, to pounds harvested to total up to about 209.6 million pounds. Also interesting, I think, from this table is it gives us an idea of what our expectations would be on how that harvest will be distributed amongst commercial fishing districts. We have a really kind of a large 3-ocean forecast this year. So that's 1-3s and 2-3s, most of that falling in the 1-3 age category. And so we can see that the Nushagak district, our expectations would be that it will take the dominant proportion of the harvest coming in 2025. Owing largely to a large 1-3 prediction for those Nushagak district rivers. So a little bit more on a forecast in pounds. We both take that inshore harvest estimate in numbers of fish, and to multiply it out, we have to come up with what we feel is a reasonable estimate or expectations for Bristol Bay sockeye size in 2025. And so now what's popped up on the middle of the screen is the data set we use to come up with an estimate or expectations for Bristol Bay sockeye size this coming year. The numbers we chose to use was 4.6 pounds for 2-ocean sockeye. This will be across the bottom there, and 6.1 pounds for 3-ocean sockeye. So the data set there for those 2-ocean sockeye are the blue data points connected by a blue line, and the data set for the 3-ocean sockeye are the red data points connected by a red line. And so you can see our expectations for 2025 there on the far right. This data set runs across the time series of 1980 to 2024. And then those data points highlighted with yellow on the far right would be our expectations for 2025. I'm sure it'd be easy to notice that we do expect a little bit of a rise in sockeye size there in Bristol Bay coming this year relative to the last 5 to 6 years. But not as big as certainly we've seen across the 80s and 90s and the early 2000s. How we get to an estimate for Bristol Bay sockeye size is really straightforward business. We basically take from this data set, and we separate it out by 2-ocean and 3-ocean fish. We take the 10 runs, we boil this data set down to the 10 runs that are closest in total run size to our expectations for 2025, and we take an average for 2 ocean, and we do the same thing for 3 ocean to come up with expectations for sockeye size in this coming year. So that brings us back to this forecast in pounds. And with that, I'll stop with the review of the 2025 preseason forecast, and we can certainly try to field any questions that folks might have.
Thank you, Chris. Yeah, folks, feel free to type a question in via that Q&A or raise your hand to ask out loud. While we give folks maybe another minute, I think what I'm understanding, I just wanted to clarify, is the ocean years are really what makes the fish bigger. Is that right? Because the two,
Yeah, they do. That's right. So salmon, and in particular here, sockeye salmon, do greater than 98% of their growth in the marine environment. So really, the difference in size between a 1-2 and a 2-2 is almost negligible. You'd have to sample a lot of fish, and it would be a very, very, very small average difference. It's really all about, in terms of size, it's what drives that is ocean age. And year to year, there will be you'll have different size at age, but within a year, certainly it is ocean age that drives those differences.
Thank you. Just kind of a logistical question here, if the charts will be available after the meeting. Yes, I believe I'll be able to post those. Is that right, Chris?
Yes, absolutely.
We'll make those available. Thanks, Dale. Okay, thank you, Chris. And there'll be more time. If you think of questions later, we'll have all our presenters on for the whole time. Oh, got a question here from KJ. He says, how does Bering Sea temperature this year compared to previous years?
It's a great question, and we are just about to hear a very detailed talk about that very subject. So I'm gonna leave that to the next talk because Daniel's about to go into that in detail.
Thank you. Yeah, I'll welcome Dr. Daniel Schindler. Daniel is a professor and a principal investigator with the University of Washington Alaska Salmon Program, with special focus on how aquatic ecosystems respond to changing climate and land use interact with the fisheries. Welcome, Daniel.
Thanks. And shoot, I'm trying to share here, and it's computer's covering up the little. There we go.
All right.
All right, can you see that, Francis?
Yep, looks great.
Okay, yeah, thanks for this opportunity to give you guys a bit of an update on 2 things. One is an update of in-season assessment tool we've started using that's looking at the size of fish at age, as Chris was just talking about, as an indicator of run size. And then the second that follows on that last question, which is what's the status of the climate conditions in the Northeast Pacific. So just to step into the first part, what I'm showing here is basically the timeline that data become available to interpret and forecast what the run strength is in Bristol Bay. So if we go back, let me just get my thing going. Oops. Getting the highlighter going here, hopefully. Okay, so if we go back to the fall, basically, it's when Alaska Fish and Game does the run reconstruction, which basically takes all the fish that were observed last year and puts them into the right river in terms of catch, publishes the escapement data, etc. And then in November, we produce a preseason forecast, which is what Chris just presented. And then long winter goes by and people are gearing up for May and the fishing season starts. And typically the big question then is, well, how is the run going to be different from what the preseason forecast was that we in the department released back in November? And that's typically done with in-season analysis. So Curry in particular does a lot of analysis of the port molar catches, of the accumulating catch and escapement into the districts. And in June and July tries to estimate how many fish are truly coming back and to which districts are they returning. And that's basically an update of our preseason forecast. The reality is we typically don't have a confident idea of what the run actually did until about the second week of July, after which the peak has occurred. If we then continue forward, one of the things we've started doing the last couple of years is what we call a preliminary forecast, which is by the end of, well, I guess the early August, after which Fish and Game has released their estimates of the total catch and escapement for the season as a preliminary estimate of that. And then also the age composition, we've started producing a preliminary forecast for the following year. But going into this fishing season, what we'd really like to be able to do is interpret as early in the season as possible how many fish are actually coming. And what we'd like to know, whether we're a manager or a processor or someone in the fleet, what we'd like to know is how good was that preseason forecast? And what we've been doing recently is using the size of fish as an indicator of how big the run is. So the department puts a lot of effort, a heroic effort actually, into aging fish and measuring their lengths as they show up in the port molar test fishery and in the first escapement projects early in the season. So that's in mid to late June. And by the end of the season, there's a pretty good correlation between the average body size of ocean age 2 fish and how big the run is. So fish are small, fish are smaller, so they're about 480 millimeters long. So that's 18 inches long when the run is really big. And when the run turns out to be small, the fish are several inches bigger. And the same is true for the ocean age 3 fish. And on the bottom panel, what we're looking at here is how early in the season can we estimate with a high degree of reliability what the average size of fish is. So the first data become available from the department in mid-June. And as the data accumulates, we can get within about 1% of the seasonal average body size by roughly June 24th. So we can get within about 1% error of the real body size that we'll see over the course of the whole season. And that's achieved by the last week of June. And the relationships is even a bit stronger for the 3 ocean fish. We then incorporate that into a forecasting model that is used as part of the in-season stock assessment, and it accounts for this effect of the sockeye abundance on their body size. So as sockeye runs to Bristol Bay get big, the fish tend to be smaller. And then on top of that is the reality that the number of pink salmon in the ocean has really built up through time. And when pink salmon are abundant in the previous year, Bristol Bay sockeye tend to be a bit smaller. So going into the season, we know how many pink salmon were in the North Pacific in the previous year, and we account for that in the model. So if we get really small fish, small for size at age, that means one of two things. It means either there was a lot of pinks in the ocean and or there's a really big return of sockeye coming. Alternatively, if the fish that are sampled early in the season are relatively big, that turns out to mean that the run coming back is relatively small. So in the dots here are the observed run sizes, And in the solid line is our in-season forecast that includes the size at age estimate. And what you can see is it tracks through the observations pretty well. These are 1 year ahead forecasts. And on the bottom is the performance of this in-season forecasting method, where the weighted here in blue is where we use the observed size at age within the season to update the preseason forecast, which is shown in red. The bars are the observations. And what you can see is that in most years, the blue dot is closer to the real return than is the red dot. There are some years where the opposite is true. But in general, size at age provides an update to the preseason forecast, and in most cases confirms whether or not it's a small versus a large run. And in most years, it actually produces a in-season interpretation that's closer to the observed value than the preseason forecast alone. The important thing is we can do this by about June 24 to 28. So the last week in June, we're getting an update or a confirmation of our preseason forecast, which should mean a lot if you are trying to make decisions about when to head home, when to stick around or transfer districts based on an improved expectation for how many fish should be returning in that season. And this is just a correlation between the predicted run size based on this method versus the observed run size. And as you can see, that's a really good correlation, that the model is doing a good job at predicting big returns in big return years. And it's also doing a really good job at predicting small returns when in fact the year had a small return. So this is where the fish are big for their size. This is where the fish are small for their size. And then just to emphasize this point once again, we can do this by the end of June. So in blue here is the performance of the in-season method that Curry leads during the summer. And you can see that by using data from, say, the port molar catches and the accumulating catch and escapement in the fishing districts and in the rivers, that our errors in our expected run size in the first couple weeks of the season are pretty high. They're on the order of 25 to 20%. And of course, as the season progresses, the errors get smaller and smaller. And at the end of the season, of course, are zero, because by that point, we know exactly how many fish returned. But this is the weighted model that includes size at age. And you can see that it's pretty stable at around 12% error. And that this is achieved by that last week of June. The additional piece of this that's really important to appreciate is just because you're seeing small fish in your nets doesn't necessarily mean it's a big return. You have to wait to know, are those small fish because they're two ocean fish, or is it because they're small two ocean fish or small three ocean fish? So the size at age data that Fish and Game puts a lot of effort into collecting are absolutely critical towards interpreting how average fish size translates into run size. And as Chris just outlined, the expectation for next summer is that there's a pretty big return of three ocean fish coming. So I think Chris can correct me, but I think roughly 2/3 of the fish expected back are going to be three ocean fish this year. You should be seeing lots of big fish because they're three ocean. But the question is, once we age them, once Fish and Game ages them, are they big or small for that age? And that's the critical input to this updated model. And we'll plan to give an update of the preseason forecast that uses this interpretation of size at age, and that usually comes out the last week of June. Okay, moving on to the state of the climate in the North Pacific and Bering Sea. Anyone who watches the news or watches the weather or pays attention to being outside is the last few years we've had some pretty remarkable temperature and climate conditions that we've experienced throughout the Pacific Northwest and in Alaska. And it turns out that the climate has had very important effects on how productive Bristol Bay stocks are over the last few decades. And as a rule of thumb, when the North Pacific and the Bering are warmer on average, we tend to get more production higher productivity of Bristol Bay stocks. So for reasons that we don't fully understand, in springs when the smolts leave Bristol Bay rivers and encounter warmer than average conditions, they tend to have above average survival rates. And when smolts have hit the ocean and it's colder than average, they tend to have lower than average survival rates. And that shows up a couple of years later in terms of the returns. During the last decade, of course, we've seen these exceptionally high returns, numbers that we wouldn't have believed back in the 70s and 80s. And those really high smolt survivals in the ocean were associated with relatively warm summer sea surface temperatures in the Bering Sea. So what I'm plotting here, of course, is Alaska, shown here in white, down here south towards Washington. And then what's plotted in color are the temperature anomalies. So what this means is basically the color is showing how different is the temperature in that part of the ocean for that period of time relative to the average. And when things are yellow, orange, and red, it means they're warmer than average. When they're white, they're about average. And in conditions where they're blue and purple, they're colder than average. So for from the 2014 to 2019 timeframe, things were generally warm, and that's a good explanation for why we saw such big returns 2, 3, 4 years later. If we look at the last few years, this is relevant to the fish that will be returning this year. We can see in 2020, there's lots of orange and yellows here. So sea surface temperatures in Bristol Bay were warm during the summer in 2020. They were warm again in 2021. By 2022, they were average or a bit cool. 2023, they were cold to average. And 2024, they were relatively cold. Okay. So if we're looking at fish returning this year, the two ocean fish left in 2023. So they encountered cool to average temperatures, which might be an explanation for why we expect a relatively modest return of two ocean fish this year. The three ocean fish we're expecting to see this year left the rivers as smolts in 2022. And once again, they were encountering sea surface temperatures that were cool to average. So based on the temperature alone, we might expect slightly lower returns than the forecast is telling us. But the point is that, the sea surface temperatures seen in 2022 and 2023 should not lead us to believe that we're going to see an enormous run once again. We're going to see a pretty solid run of around 50 million, as Chris talked about, which for the last decade has been roughly average. Going into 2024 sea surface temperature conditions, things were quite cool in 2024. So we'll see the first jacks coming back this year. So based on temperature alone, we might expect to see very few jacks this year. But 2026 and 27 is when these fish will return as adults. And based on the sea surface temperature, we might expect lower than average returns a couple years down the road. But for this coming year, there's nothing really exceptional about the sea surface temperatures when the smolts left the rivers, which doesn't give me any cause for alarm looking at the forecast. To put this in a time series perspective, this is the Eastern Bering sea surface temperatures during the summer from 1950 to the present. And what you can see here is between 2014 and 2019 were these really record-setting warm temperatures, the warm blobs as they became to be known. And this is that cooling trend we've seen in the last 3 to 4 years. It's still much warmer than the long-term average, but it's not continuing to ramp up into these really exceptionally warm conditions that were starting to cause some concerns and were associated with all sorts of bird die-offs and some other wildlife die-offs in the Eastern Pacific. If you look at the Gulf of Alaska, same thing. We see this really steep ramp up in the mid-2015s. These are the warm blob years and a little bit of a cooling trend in the last couple of years. It's still above the long-term average, but it's nowhere near as hot in the last couple of years as during those warm blob years. So that's a bit of a cause for relief when you think about what long-term trends we're probably on with ongoing climate warming. And then the last thing, I do show this, I think, every year, but basically keep in mind that the Eastern Bering Sea, of which Bristol Bay, of course, is part of, is much cooler than the Gulf of Alaska. It's on the order of 3 to 4 degrees Celsius cooler. And this is much more in the realm of what's optimum, or what we think is optimum for smolt survival in the ocean. Gulf of Alaska rivers, they're dumping into an ocean that's getting particularly warm, and associated with this has been some decreases in productivity of rivers dumping into the Gulf. But Bristol Bay continues to be in what we think is a sweet spot for smolt survival. Okay, I'm hoping this is going to work, but what I'm going to show you here is a animation that reconstructs the temperature regimes of the North Pacific over the last year. So I'm going to start with basically today and just to orient you. Here's Alaska, here's the peninsula. So underneath my red dot here is Bristol Bay. And the color scheme is the same as in previous slides, where blues are cool, oranges and reds are warmer than average for this time of year. So right now, both the Gulf of Alaska and Bristol Bay are showing yellow and red and orange, which shows that things right now are warmer than average, where the average is calculated between 1990 and 2020. So things are pretty warm this spring, and I just want to show you, hopefully, how that has developed over the last 12 months. Okay. Francis, can you confirm that this new slide is showing?
Yep,
Yes.
it updated.
Okay, thanks. So this is last spring. This is 2024, June 16th. And let's look here at Bristol Bay, and you see a lot of blue up there. So last spring was colder than average in Bristol Bay and in the coastal Gulf of Alaska. So if you remember back to last year, we were shivering last spring, and the fish were encountering relatively cold water. On the equator, there's a blue strip right here on the equator, which is a signature of cool water sitting in the eastern tropical Pacific, which is the end of what was a La Nina. Okay. And in Bristol Bay and most of the Bering Sea, things were colder than average last spring. And let's just click ahead a few months. We'll go to the beginning of August. And what you can see here is August also is relatively cool in the Bristol Bay. Off the California Current and the Pacific Northwest, things were quite warm, but Bristol Bay fish were encountering cold water last year. We'll click ahead to first week of September. Again, last year remained cold. And then we'll click through the fall, moving into, this is around Thanksgiving, mid to late November. Lots of white up here. That isn't ice. In this case, it means that the conditions were about average for the last 2 or 3 decades. Clicking forward to New Year's, again, things are white, relatively average conditions. And then we're going to start moving into this winter. And as we click through, we start to see oranges and reds show up. Okay, so here's end of January. Sorry, that was end of, what was that? That was end of December. Here's early January. Clicking through this winter, we're seeing lots of reds and yellows in the Gulf of Alaska and in Bristol Bay. The point is, it's been a really warm winter up there in the coastal ocean. This is continuing through. Here's early April. Again, lots of yellows and oranges. And we're going to click through till right now. So here we are, the second week of May, and things are white, yellow, and orange, which means that things continue to be warmer than average this spring in Bristol Bay. So I just want you to take a look at this image here, which is right now up in Bristol Bay, and then I'm going to compare that to where it was last year in May, and that's what last year looked like. It was much colder last year compared to where it is right now. Okay, let's see if I can get back to my slides now. Oh, yeah, here we go. Okay, so what's the forecast? This is a forecast for this coming summer produced by NOAA, or what was NOAA, I guess. And what you can see is that using these data, this forecast was actually produced about 3 months ago, is NOAA is expecting a relatively warm summer. So this warming trend we've seen since about New Year's is expected to continue. And, basically all data suggests that you should be expecting a warmer than average sea surface temperatures in Bristol Bay and in those fishing districts. We've put a lot of effort into the years into assessing whether this means anything for run timing. And, there's really not a lot of indication that water temperatures affect run and timing. But of course, water temperatures do affect how easy fish are to handle from nets and get them to processors, etc. But I think the bottom line is here, you should be expecting pretty warm water temperatures this June and July of the fishing season. So what's the outlook? Is that the sea surface temperatures during 2022 to 2024 were about average. Last year was maybe colder than average, but for whatever reason, the conditions have flipped and we're expecting really warm average temperatures this spring for most of Alaska. The La Nina that was really evident for the last couple of years pretty well disappeared this winter. And for most of the North Pacific, including the Bering Sea and Bristol Bay, we're expecting warmer than average conditions for this coming summer. And I think that's my last slide. Yeah.
Thank you. Yeah, while we transition here, feel free to type a question or raise your hand to ask one. And then we'll move on to hear from Dr. Curry Cunningham, who is a quantitative ecologist with the University of Washington Alaska Salmon Program, a former Bristol Bay commercial fisherman, professor at the College of Fisheries and Ocean Sciences, University of Alaska Fairbanks. His research focuses on population dynamics and fishery management. Thanks, Curry.
Thanks, Francis, for the introduction, and great to see some familiar names online today. It's always exciting to chat with this group as a former Bristol Bay kid. So in general, I'm going to talk about sort of 3 topics that really connect up well with what Daniel was just talking about in terms of the state of the climate. I'm first going to talk about some work that we've had ongoing in collaboration with NOAA and the Alaska Department of Fish and Game to look at juvenile sockeye salmon out in the eastern Bering Sea that are caught in surface trawl surveys and what they tell us about the number of sockeye returning to Bristol Bay in the coming years. I'll talk a little bit about one thing that's been kind of at the top of our minds since last year, and that's that small size of sockeye in 2024, kind of thinking about what conditions might have set that up. And then I'll talk a little bit about our preliminary preseason forecast that Daniel discussed briefly, which is sort of a new product that we're trying to do sort of close to the end of the fishing season to give people an even earlier look at what might be coming down the pipeline prior to our formal preseason forecast that goes out in November of every year. As well as some of the online products that we try to put out for the fleet and the Bristol Bay seafood processors that we update on a regular basis. So diving into the first topic, as Chris talked about, traditionally our preseason forecasts have primarily been based on the number of fish that return to a river system in a previous year and what that tells us about primarily early marine survival and therefore the return of older fish or fish that spend additional years in the ocean in subsequent years. But there's a really unique source of information that lies offshore. So since about 2002, NOAA, and in partnership with the Alaska Department of Fish and Game in the context of the Northern Bering Sea, have been conducting surface trawl surveys that generally take place in September or October. So they catch a range of juvenile salmon, but are catching Bristol Bay sockeye in particular in sort of September or October of the year that they go to sea. So as Daniel was just talking about, the environment and particularly temperature may play a role in how well these juvenile sockeye survive when they hit the ocean. This surface trawl survey gives us a peek at actually how many were out there and maybe how well they survived both in the freshwater portion of their life as well as after they've hit the ocean, or at least for the first few months that they're at sea. So what I have plotted here is just the time series of survey observations that have taken place out there. As I said before, it's a surface trawl survey, really well designed for catching juvenile salmon. One of the key challenges is that the sort of spatial footprint or the distribution of these observations or the stations that were towed year over year has varied quite a bit, just based on available funding and survey effort, and the fact that there's sort of a combination of two surveys that are stitched together. The Northern Bering Sea is surveyed every year. Southeastern Bering Sea, the offshore portion, is surveyed on alternating years by one of the NOAA white boats. More recently and really excitingly, ADF&G has a new trawl vessel, thanks to a donation from the industry, that's been refurbished. And so last year and moving forward, there'll be some more nearshore observations of surface trawls in and around the Kuskokwim and Bristol Bay. But all to say that these surface trawl survey data indexing juvenile salmon really can provide, I think, some useful information for the number of adults we expect to return 2 and 3 years down the line after that survey occurs. So what I have plotted here up in black, this is the actual survey year, or the year of outmigrating sockeye that's being indexed. One of the nice things relative to maybe juvenile king salmon or juvenile chum salmon that are caught in this survey, the vast majority of sockeye that are caught in this survey are of Bristol Bay origin. It's the dominant producer of sockeye in the region. So we don't really need to be considered with sort of the mixed stock analysis or using genetic techniques to break up the juvenile catch and allocate it back to Bristol Bay. They're mostly Bristol Bay fish. But up on top, this is the year of outmigration, or the year of the survey. In red here, this is the years that individuals that outmigrated in that year and would be caught in that survey would be returning as 2 ocean fish or 3 ocean fish after 2 winters in the ocean or after 3 winters in the ocean. This is the predicted abundance per kilometer squared. It's in log space, but basically what it shows is the more yellow colors are higher predicted abundance in a given year at a given point in space for juvenile sockeye. The more blue colors, lower relative abundance. So one of the things that we can see, if you sort of look across, you pick up these periods of time where there's more yellow than blue. So starting in about 2014, so fish that outmigrated in 2014 would have returned as 2 ocean adults in 2016 and been available to the fishery, and as 3 ocean adults in 2017. In this case, we see a couple of distinct periods. In 2008 through 2013, there was definitely distinctly less yellow here, lower relative abundance of juvenile sockeye in the Eastern Bering Sea. Once we enter this 2014 period all the way up through 2019, we see higher predicted relative abundance of juvenile sockeye in the Eastern Bering Sea. And this tends to coincide with what we saw in terms of returns to Bristol Bay in subsequent years. When we translate that into, or kind of sum up across space, we can get this index of juvenile sockeye abundance in the year of outmigration across these outmigration years, and that's what these bars are. And you pick up this period of time. So in this period from 2008 to 2013, we saw lower abundance of juvenile sockeye in the Eastern Bering Sea. Starting at about 2014, we saw really high abundance, or higher abundance, of juvenile sockeye in the Eastern Bering Sea, culminating in 2019. 2019, across this time series over which these surface trawl surveys have been conducted, the highest single year index for juvenile sockeye in the Eastern Bering Sea is from 2019. There's a gap here, so no survey in 2020 due to COVID, and after that time, we've seen lower abundance of juvenile sockeye, at least based on those surface trawl surveys. So, that's all well and good, right? We've got this index of juvenile sockeye in the Eastern Bering Sea, gives us an idea of the number of juveniles out there in the year of outmigration. But if we want to translate that into a forecast for future years, we basically need to allocate those outmigrating individuals, or that index of juvenile abundance in the year of outmigration, sum up across individual outmigration years for a return year. So when those fish are going to be returning as adults. So for example, here in 2025, the fish that are returning as three ocean fish in 2025 went to sea in 2022. So we want to consider that juvenile index in 2022 and add to that some sort of portion of the juvenile index from 2023. Those fish that went to sea in 2023 are going to be returning this summer in 2025 as two ocean fish. So by considering the outmigration or juvenile indices from a couple of different years, we can come up with a prediction for how many fish are returning as adults 2 to 3 years down the line. And so taking that juvenile high seas index, sort of looking forward in time, allocating it out to the calendar year that those juveniles should be returning, we can look at the relationship between that index of high seas salmon abundance by return year and how that relates to Bristol Bay run size historically. So each of these points is an individual year from 2005 up to 2025. On the x-axis is just a different way of treating that sort of high seas prediction for juvenile abundance and how that relates to Bristol Bay run size in millions on the y-axis. So what it says is in these years where we saw reduced sort of number of juveniles in the Eastern Bering Sea, 2 to 3 years later, you tended to see lower abundance of adults returning to Bristol Bay as a whole. So these bars here of the observed run size in millions, 40, 60, 80 million. Of course, 2022 stands out in all of our memory as the record-setting year. These lines are the model predictions from just two ways of looking at those juvenile data, and they captured this period of lower run size in Bristol Bay, this increase after 2015 that we've all seen, and this high water mark here in 2022 and 2023. So how well does this do? We talked about, Chris talked about kind of mean absolute percent error. One of the nice things about this juvenile based forecast method is that it does pretty well. You've got an error rate, depending on how you look at it, across this period of time from 2005 up through 2024 of about 12%, which is pretty darn good. That's for Bristol Bay as a whole. Obviously, this doesn't tell us anything about river system by river system, or pretty limited information in the way that our formal preseason forecast does. But one of the benefits is that it gives us a look 2 years out into the future. So looking at survey data, Eastern Bering Sea surface trawl survey data through 2024, that gives us a peek at what we might expect in terms of adult returns to Bristol Bay in 2025 and 2026. And it looks like some stability in 2025, somewhere around 53 million, pretty consistent with the preseason forecast that Chris presented, which gives us some additional faith in that number. But a prediction for a reduction into 2026, somewhere down there between 43 and maybe as high as 53, but this decline between 2025 and 2026. Now, with that in mind, I think it's really interesting to think about the sort of story of the small fish we saw in 2024. As Chris talked about already, the key driver of the size of fish we see in our nets or in the escapement upriver is the ocean age. And so what I have plotted here is from 1984 up through 2024 is the proportion of fish that returned to Bristol Bay, or the percentage of fish that returned to Bristol Bay as two ocean, so smaller two ocean fish in yellow, or larger three ocean fish in blue. And one of the things we've seen over the last 2 years, so this is 2024, this is 2023. In 2023, there was about 80% three ocean fish. And we swung from that down to about 83% two ocean fish in 2024. So the small size of fish we saw last year in 2024 was a combination of the fact that they were majority 83% two ocean fish, mostly 1-2s, and there was very small size at age. So as Daniel talked about, in addition to the overall age of a three ocean versus a two ocean fish, the size at age can vary over time. And so this combination of predominantly, I mean, almost record-settingly high proportion of two ocean versus three ocean fish, plus the small size at age contributed to what we saw in terms of overall small size and small weight of fish last year. This is really fascinating, this transition we saw from 80% three ocean fish in 2023 to 83% two ocean fish in 2024, because it tells us something about 2019. So 20 fish that were spawned in 2019 that are from the 2019 brood year would have returned as 1-2s in 2023 and 1-3s in 2024. Well, what did we see in 2024? A notable absence of three ocean fish of 1-3s. So it suggests that there was something going on in 2019 that led to a little bit lower production or survival of fish, given that we saw an absence of two ocean fish in 2023 and an absence of three ocean fish, or a lower number of three ocean fish in 2024. So it turns out that 2019 was a really fascinating year. So as I was just showing from the juvenile data, the fish that went to sea in 2019 did really well. Those fish returned as two ocean fish in 2021 and in superabundance as three ocean fish in 2022. The other side of that is that fish that were spawned, or eggs that went into the gravel in 2019 seem to have had lower returns in the last 2 years. And so, of course, this sort of begs the question about what was different in 2019. Well, I think most of us remember how hot it was in 2019, thinking about stress on adults migrating upstream and some of the river systems. What I have plotted here is just the time series of surface temperatures in Lake Iliamna in August when fish are spawning. And so what you see, much like the sort of broader Eastern Bering Sea pattern, is that 2019 was just record-setting hot in Iliamna in 2019. So again, two sides of that coin. If you went to sea in 2019, you did pretty well. If you were spawned in 2019, it seems like production was a little bit lower. The reason I bring this up is, one, thinking about the size of fish we saw last year, but also thinking about how 2025 is setting up, right? There's little to no snowpack. I'm sitting here in Juneau, and we've had a mediocre ski season at best. Little to no snowpack across Southwest Alaska, some later on snow, and going into what potentially looks like could be a pretty warm summer from the perspective of the sea surface temperatures that Daniel was just showing. We may have the potential, depending on how things play out, to see another really warm summer like 2019. And if we got any sort of snapshot of what that means, it means that, from an outmigration perspective, that may be good, but certainly for at least some river systems on the spawning grounds, maybe at the upper end of the temperatures we want to see. Okay. Daniel already talked a little bit about the preliminary preseason forecast that we put out, but I just want to highlight a couple of the products that we're trying to put out there for the fleet and the processors. So as Chris alluded to, we put out our formal preseason forecast in November of each year, which provides the predicted run size by river system and by age class, and provides a prediction for the catch, both in numbers and in weight by district. That's really useful for those of you trying to figure out where to drop your card. What the preliminary preseason forecast does, that comes out in basically August, so prior to that November formal preseason forecast, is it gives us a sort of initial snapshot. So the folks at Alaska Department of Fish and Game do a fantastic job of putting those data together as the season progresses, and by sort of the end of August, there's a general sense of what the total run size is, of course, and then what the age composition was, so we can put out this sort of preliminary preseason forecast. It The value is that, you know, it comes out in August, late August. It has a little bit higher error rate. So we often think in mean absolute percent error terms, about 19%. Our formal preseason forecast has an error rate of about 15% and breaks it out by river system. But at the end of the day, that preliminary preseason forecast from August was about 49 million. We updated that to 54 million once the final data were in. So trying to provide as much information as possible in the lead up to the season. The other two products I want to highlight. So in the midst of the fishing season, as Daniel talked about, we're quite focused on providing in-season information through our in-season forecast, where we update our preseason forecast as real-time information comes in from the Alaska Department of Fish and Game and the folks at BBSRI. So there's two main products. One is a website that we update on a daily basis that has a series of useful figures comparing, you know, total catch and escapement by district and for Bristol Bay as a whole to what we would expect based on the preseason forecast. I've got the link there. I've got a QR code, but basically something you can pull up on your phone and look real quick and say, okay, how's the run tracking with what we expected under the preseason forecast, and some other sort of basic summary figures that I look at every day. We also put out our comprehensive in-season reports about every 5 days. And again, the links on here, which provide a more detailed breakdown, at least of our interpretation of how the run's stacking up to the preseason forecast, any oddities that we see, or whether or not the percentage of the run by district looks different than what we thought in the previous November as the data roll in. So right here, this is the QR code for that in-season website. I think we're going to distribute the slides after this, but thanks for the opportunity to chat. And of course, you know, this sort of analysis and research in Bristol Bay is not done in isolation. So huge thank you to the folks at ADF&G who collect a lot of these data, the folks at NOAA that run that offshore survey, and the folks at BBSRI that obviously run the Port Muller test fishery.
Thank you. All right. Yeah, I'd like to welcome Dr. Ray Hilborn. He's a professor and principal investigator in the University of Washington, and has worked with the Alaska Salmon Program since 1995. Dr. Hilborn works on science management and salmon management, including escapement goals and run forecasting, and comparing the environmental footprint of Bristol Bay Sockeye to other sources of food. Welcome, Dr. Hilborn. Slides look
Okay.
good.
Good afternoon, and thanks for the opportunity to share some thoughts on what we see as one of the biggest issues that's confronting the Bristol Bay system, which is built around managing weak stocks, and in particular the Nushagak King and Nushagak and Sockeye trade-off. I just want to give you some background on this, and it's an area that we are discussing and hopefully doing some work. We're in contact with Alaska Fish and Game over these issues, because they are the managers of the stocks, and I know they're extremely concerned about this. I think everybody's pretty concerned. So I want to just review some of the basic issues. So within the Fish and Game system, there's three kinds of escapement goals. There's biological escapement goals, which are based on the analysis of spawner recruit data. Then there's the optimal escapement goals, or OEGs, which allows for sustainable runs based on the biological needs of the stock and assures healthy returns for both commercial, sport, subsistence, cost recovery, personal use fisheries, and they'll be set by the Board of Fisheries, whereas the biological escapement goals is based on analysis done by Alaska Fish and Game. And then there is the sustainable escapement goals that is really just levels that have been shown to be sustainable. That is, they produce good but not maximal returns. If we look within the major systems in Bristol Bay, we'll see, let me see if I can move this thing out of the way a little bit here. How do I minimize this? That's this one here, I think. No? That one, no. Oh, come on, move. There we go. Okay, whoops, then I got to go back. So we see that for most Bristol Bay systems, there are in place sustainable escapement goals that the Board of Fish switched from mostly biological escapement goals back about 10 years ago to SEGs, really because if you do the biological escapement goal analysis, you end up with some very, very large escapement goals, and suggesting that allowing a lot more fish to escape would produce bigger runs. But as I think we saw in 2022, that bigger runs in the long term are not necessarily better for the system. And so the Board of Fish adopted sustainable escapement goals with some differences. And for the Noosh Kings, which is the big concern, those are also sustainable escapement goals. And then there are levels of concern, yield concerns. So stocks would be classified as, are they of concern? And yield concern is when you're simply not able to maintain the escapement goal targets. Whereas management concerns are when you're chronically unable to maintain escapement goals above the lower bound of the escapement goal. And then finally, there's the stocks of most concern or conservation concerns when the stocks continue to be at low escapement below what is called the sustained escapement threshold. And so a stock of conservation concern is this inability, despite the use of all the management measures, to maintain above the sustained escapement threshold, and it's the most severe level of concern. Now it's defined as a level below which the ability of the stock to sustain itself is jeopardized, and when in place, a sustainable escapement threshold is established by Fish and Game in conjunction with the board, and as needed, a stock of conservation concern then mandates a formal rebuilding plan to rebuild within 10 years. So that has some analogies to the federal requirement for rebuilding. But there's a lot of issues about this. So one of them is, are we seeking to maximize pounds caught or economic value? Because large catches usually end up reducing the price. And then the question is the escapement goal in the number of fish or the number of females or the number of eggs? Because one of the things we've seen in recent years is the size of fish has been declining, which means the number of eggs has been declining. So if you were to go to escapement goals in terms of egg production, then in general, with these larger runs, your escapement goals would increase. But another issue, which hasn't been too much of an issue within the Bristol Bay system, is that the escapement goals have traditionally been based on maximization of sustainable yield, and that really assumes that every fish in the catch is of equal value, regardless of whether it's a big year or a small year. So whereas if you think about subsistence fisheries, which has been a really recurring problem in a lot of Western Alaska, fortunately not in Bristol Bay, is that the first 1,000 fish are really worth more than going from, say, 100,000 catch to 101,000. So, and the economists call this diminishing marginal utility. But when runs are low, the first fish, particularly for a subsistence fishery, are more important than then if you've got lots of fish, then another 1,000 fish aren't that big a deal. And then another big issue we're seeing again, certainly for what appears to be for Nooshgat Kings, is the productivity appears to be declining. And so if the productivity declines, then your BEG would be lower. So you've got sort of two things potentially going on. You've got smaller fish saying you'd want to increase your goal to maintain the number of eggs, but if the stock's becoming less productive, then you actually want to lower the escapement goal. I'm talking in terms of mixed stock fishing. This has been a subject of scientific interest for a long time, going back to a classic paper in 1958 by W.E. Ricker. And it really just is about, if you've got a mixed stock fishery, then the optimal yield depends upon the mix of the stocks. But the bottom line is this, that if your goal is maximization of long-term yield, you would overexploit the weaker stocks. You would overexploit the weaker stocks because you're going to be aiming for the whole mix of the stocks, and you would underexploit the strong stocks and you would overexploit the weak stocks. So if we think specifically about Noosh Kings versus Noosh District Sockeye, that essentially we know how to calculate the best management objective if we know what the objective is. That if our objective was the economic value of that fishery, we know how we could calculate what the right mix of harvest on kings and sockeye would be. But, and this is a big problem in this, is we have to have faith in the data. As I think everybody's probably aware, there's serious concerns about our ability to count, particularly kings, but also sockeye, with these big runs in the noosh. But if the goal is the economic value, we can calculate the value of a sockeye in the catch and the king in the catch, even if released for a sport fishery. We could calculate how to maximize the value of the mixed fishery. So that's one issue, is how would we be balancing the king versus sockeye catch? And the particular is this, how much should we forego early season sockeye in the Noosh district in order to get higher escapements of Noosh kings? And that really depends totally on what our objective is. But there is also just the basic question of, should the Nooshgat kings be listed as a stock of conservation concern, and thus subject to a mandated 10-year rebuilding requirement? It would have a major impact on the sockeye fishery, and it would depend on what was set as a sustainable escapement target, the threshold. And that hasn't been set at the moment. It would depend on what we assume about changes in the stock recruitment relationship. And there, as I mentioned, we have this declining in the recruits per spawner, that for the Noosh kings, and we've also got a decline in the body size. So what we hope to do is really develop some formal alternative methods to calculate how you would do the sustainable escapement threshold for all the potential stocks of concern. And it's particularly important for almost all Alaskan Chinook and chum. Specifically look at Nushagak River kings. This is not something we can do on our own. It has to be with our existing collaboration with Fish and Game, BBSRI, BBRSDA. And one of them is, and this is something that Fish and Game is particularly worried about, is how do we correct the historical count data for the shadowing of fish at Portage Creek sonar sites. And we know, or everybody, the Fish and Game knows that, that's good. That is, we know that when they have a high fish passage on a day at Portage Creek, that you just don't see all the fish because there are so many, they're shadowing each other. We're hoping to find a way to do some work on this in the next year. So I'll stop there and pass it back to Francis.
Thank you, Dr. Hilborn. Yeah, there's a lot of focus and concern around the Nushagak kings and what we can do. Thank you. I'd like to open it to any questions for any of our presenters. Feel free to type them or use the raise hand feature. I will post the recording of this presentation if you want to look back at something or share it with someone who wasn't able to be here. And I'll send that to you. I have your information because you registered for this. Well, thank you all very much for presenting and giving us your time. I find it fascinating and really important science that is helping keep our fisheries strong. So thank you so much for your time, and thank you for everyone for attending as well. Really appreciate it. Oh, I've got a hand. Ray.
Yeah, I wanted to ask Curry if he has any idea if the juvenile survey is going to operate this year with all the funding cuts.
Yes. So we put in thanks to the AKSSF, which funds part of that survey, along with contributions for the Northern Bering Sea portion of it, with contributions and in-kind support from Alaska Department of Fish and Game. It is moving forward in this year. That funding, sort of that proposal went in last year. There'll be a new proposal that goes in this year that we're just discussing now. So yes, for Southeastern Bering Sea, kind of the fate of that moving forward is a little up in the air given NOAA funding priorities, but fingers crossed.
Thank you. Yeah, the cohesiveness of that science is so important. Okay. Well, thank you, everyone. Best of luck in the preseason prep, whether it's for fishing or the field work. Thank you so much.
Yeah. Thank you, Francis.